Hey everyone, welcome to another episode of Let's Lead. Today we'll be starting with something new. We'll talk about one of the hot topics, that is deep learning, and precisely not deep learning but a deep learning framework, and with it also as well about neural networks, and that is TensorFlow. So we'll start learning about TensorFlow, the very basics. TensorFlow kya hai, how do we use it, why it is so popular, and much more. All right, so let's get started. So we'll start with a bit of theory. I know this might be a bit boring, but it is important just to understand. Then we'll quickly jump to the hands-on part, and that will also be very interesting to learn. All right, so we'll start with TensorFlow. All right, so what is TensorFlow? We have three things: what, why, and how. All right. सबसे पहला, what is TensorFlow? What is, we write it as TF. Most of the time you'll see it as TF. So what is TensorFlow? TensorFlow basically is, you can say it as a deep learning or machine learning library, which is developed and maintained by Google. All right. And it's open source. First of all, it is widely used to develop production level deep learning algorithms and deep learning projects. It was licensed under Apache 2.0, all right, in 2015. Until now, it has grown rapidly. If you see in the GitHub page of TensorFlow, there are more than 135,000 commits as of now, and more than 3,500 contributors. All right, so let me quickly show you. So if you go on the TensorFlow GitHub library, so if you see, there are more than 181,000 stars. It has been forked more than 73,000 times. All right, and it is widely and well extensively used. There is dedicated documentation as well available, so it's very widely and very popular. So we'll also learn what makes it so popular. Why is it so popular? Okay. So like I said, it's developed and maintained by Google. All right. So why? The second question is, why is it so popular? Why is it like there are more certain other libraries like PyTorch. We have Amazon MXNet, Amazon MXNet. All right, then we have Theano. So all these have certain common features, like they have auto differentiation. Basically what is auto differentiation? We'll learn more about it, but in a nutshell, it is a useful mathematical tool for optimization. So ye sare mein we have auto differentiation, we have support for popular types of framework like CNN, RNN. All right. So why is it that only TensorFlow has such wide user base? Although these also have, but compared to these, TensorFlow has a very wide user base and wide community support. Why is it so? There are few factors, definitely. First of all, it is open source. All right. Secondly, it is maintained by Google. All right, well maintained. There are actively tracking of issues and fixing of issues. There are new versions available. All right, but also it has support for popular languages like Python. All right, C++. We have R. We have Java. We have also for Go programming language. All right, so this is what makes it popular. One of the reason. Second, it is tightly coupled, and in fact from version 2.0, TensorFlow version 2.0, Keras is the standard API. So you would have heard about Keras, whoever is part of deep learning journey, but if not, we'll learn more about it. So Keras is a beautiful API basically. So it's a beautiful API. All right, which helps to develop deep learning neural networks. All right, it is used to design neural networks. So Keras has a tight integration starting from TensorFlow 2, and in fact the standard way of interacting with TensorFlow framework is via Keras. So this is one reason So it allows also model development, and there is a very ease of deployment in case of production. Whenever there is a need for production model development and deployment, TensorFlow is most of the time is the first choice of most of the developers. Last but not the least, it has very good community support. All right, very good community support. All right, so these are few reasons why TensorFlow is so popular. All right, now, so before we move ahead, like I told you, why Keras, and basically what is Keras? So like I said, it's a beautiful API, basically, which helps us to create and train deep learning models. All right. Apart from TensorFlow, it can also be integrated with multiple other deep learning frameworks. Like I said, Google TensorFlow, Microsoft CNTK, Amazon MXNet, all right, Theano. But starting from TensorFlow version 2.0, Keras is the standard standard API and a way of interacting with the TensorFlow framework. All right. So let's start off by a bit of theory on what is neural networks. So most of the time you will hear neural networks abbreviated as nets. All right, or certain of the times it will be said as ANNs. What ANNs means, artificial neural network. So what is actually a neural network? So if you think about it, in our childhood we learnt about neurons, right? It looked something like this. It had a head and there were branches. So this we were told that this is how our brain looks. So there are billions of neurons. As of now, there are more than 141 billion neurons available or present in an adult human body, along with the sensory receptors. All right. So in a human mind, basically the artificial neural network or the neural network is loosely inspired by how a human brain works, or the visual cortex of the human brain works. So what happens is, we have visual receptors in our eyes. They receive some visuals and they forward it to the neurons, which are interlinked. They pass on data from one to another, and that is how we perceive our vision and we understand things, right? So similar to that is what neuron works. So neuron is highly inspired by the visual cortex of human brain, where there are more than 141 billion neurons, as well as what we call as receptors, sensory receptors available in our eyes, right? So yeah, so this is what neural network is. We'll understand how do we create it, how do we implement, and everything will be coming forward. I'm just talking about few of the theoretical aspects. All right. Now, the very basic building block of any neural network is nothing but perceptron. All right, you'll hear about this term a lot. Okay, going forward, you'll hear something like MLP. MLP is nothing but multi-layer perceptron. You'll hear about perceptron. So what is a perceptron? So you can think of perceptron as an algorithm, and on a very basic level or very base level. Perceptron is nothing but an algorithm, which, when given a set of weights and a bias, outputs either 0 or 1. All right, 0 or 1 is nothing but 0 can be said as no, for example, or false, and 1 as true. All right, or yes. So if I depict it mathematically, perceptron is nothing but f of x. Let's say 1 when wx plus b is greater than 0, 0 otherwise. So this is nothing but a single perceptron. So when this what is wx plus b, you can think of a hyperplane. All right, so there are so if you remember the concept of linear regression, we have weights, we have mx plus c, right? M is the slope, c is the offset, right? So similarly, wx plus b, w is the weight, x are the values, B is the bias. All right, so consider it as a hyperplane. This is nothing but Wx plus B, which differentiate between two values. So the very basic representation of a perceptron is this. So this is perceptron is nothing but a mathematical algorithm or mathematical function. All right. Now this is perceptron. Now before I move ahead, before I move ahead and talk about a few more things, we'll just write a simple TensorFlow code just to see how it works. All right. So before I start, like I said, before we write a TensorFlow model, there are few ways to create a TensorFlow model, right? Or a sequential model, as you say, sequential. So directly, we don't actually directly interact with TensorFlow. We interacted, like I said, with the TensorFlow.keras API. Right, so Keras is the layer in between which helps us to integrate with TensorFlow. So we'll start with writing a sequential TensorFlow model. Sequential, you can think of sequential as stacking up of different layers. All right, we have different. We'll talk about layers. So basically, a layer is nothing but when there are multiple neurons inside it. There can be one or more than one neuron. That is considered as one layer, right? So there is typically three ways, although we can write a TensorFlow model in multiple ways. There are typically three ways to interact with the sequential API or to create a TensorFlow model. First is the sequential API. All right. Second is the functional API. And third is the model subclassing. All right. So these three are the ideal way or generally the most used ways, and even between this, sequential API is the most easy one, and that is what we will be also using. So sequential, as I said, is sequential model is nothing but a linear pipeline. All right, it's nothing but a linear pipeline, or as we say, a stack. If you remember a stack of neural network layers. All right, let's quickly write a small TensorFlow code just to give you a hands-on on how things work. All right, so I have my TensorFlow environment created. I'm using, for Python, I'm using the Anaconda distribution. You can also use the same, or it's up to you. How do you want it? I am using PyCharm as my code environment. IDE. I created a virtual environment, and inside that I have all my dependencies. All right, how can I start? What I can do is import TensorFlow STF. All right, so I'm importing TensorFlow from TensorFlow. Now I do import Keras. All right, I'll just write few variables and be classes. Let's say this is the number of classes. For example, you'll understand what this means. Reshaped 784, for example. Now I define a model. Model is nothing but tf dot keras dot models dot sequential. All right. Now I can add layers to these this model. Model dot add. What I'm adding? Sorry. Model dot add. What I'm adding? I'm adding a Keras layer, a layer basically, and a neural network layer. Layers dot dense. So what do we understand by dense? So if you think about it, dense is nothing but, let's say I have multiple layers. All right. I have this layer where there are 4 neurons. I have this layer where there are 3 neurons. I have again a layer where there are 4 neurons. When each neuron is connected to every other neuron of the next layer, so it is called as a dense layer. So this is a dense layer, this is a dense layer, and similarly if I connect everything, this is a dense layer. So when there is an interconnection between all the neurons of all the layers, that is a dense layer of that particular layer, right? If I show you the documentation for this, there are for particular variables we need to define. The units are the number of neurons, the activation function. We'll talk about activation function dedicatedly in another video. We have the kernel initializer. So like I said, every this is nothing but a perceptron, right? A single neuron. So a perceptron, if you think about it, is nothing but a neural network with single neuron. All right, so that is nothing but a perceptron. Now if you think, so initially the idea is to tweak the values of weights and bias of each neuron such that I get the desired output. Now to tweak the values, I need to start with a particular value, right? I'll initialize the values to a certain value, and then I can start tweaking it. I can either increase it, decrease it with a certain value, and that is where the concept of initializers come in. I'll talk about it, but let me first write the code. All right. So we have the NB classes. These are the number of initial layers, the input shape. How do I provide the input? So what will be the shape of my input? All right, and then we have kernel initializer. I'll just type it for time being, but you will understand. Zeros. All right, then I can provide a name of the layer, dense underscore layer. All right, then I can have the activation. I'll talk about the activation functions. All right, so this is a typical example of how can we write a small model with one single dense layer. All right, so this is nothing but a neural network with one single dense layer where there are 10 neurons in the layers, right? So spelling mistake, this is zeros. All right, now see, it runs. So this is a very typical example. We'll talk in detail about each of these. How do we do it? Why do we do it? Similarly, right? So like I said, we need to initialize the weights of each of these, and then later on, as the model trains, it tweaks the values of the weights and biases similarly, right? And to get the desired output. So what you saw here, I initialized the weights with zeros, but there are certain other ways to initialize it. Like I said, one is zeros, like it initializes everything to 0. Second is random uniform. There is another way we can do, that is random uniform. And what it does is it randomly initializes with a very small value, a range between 0.05 to 0.05. Okay, and then we have random normal. Right, so it provides the values as a Gaussian distribution. All right, where the mean is 0, and the standard deviation is of 0.05. So values between these distribution or inside these distribution, that is how it will be initialized, right? So like I told you, we have the concept of multi-layer perceptron also. So multi-layer perceptron is nothing but when multiple neurons are stacked together in different layers. All right, so that is multi-layer perceptron. All right, this was a very basic level of theory with TensorFlow. In the next video, we'll talk about activation functions dedicatedly. All right, and maybe a few other things as well along with activation function. But why, first of all, why do we need activation function? What is the need, all right, of activation functions? All right, thank you so much, and I'll be back with another episode.